use this one for Python, pretty much just because it does the job for me, and that's what I tend to be more familiar with. So if you just want to find it, then we can have a chat. Sorry? Comments. Let's start with you. Hands up first, so go for it.
It's not you write in a piece of code that gets I use it.
So normally things that are used for notes purposes or explanation or adding a bit of extra information to the code you've written, mostly for documentation. Yeah. And the easiest way to think about commenting is they say, let's say, if you're a programmer and you write a code today, in 6 months' time, you may not necessarily remember what you wrote. So you leave a bit of code to help you remember what you have written or figure it out without reading every single code line by line, right? Or if you got promoted and you have a junior programmer, for example, would they be able to understand your code in order to maybe carry on the work that you've done? Yeah, make life easy for yourself. So one thing I prefer doing, normally have a header like this. So you will build your own header that you will use in almost every code that you create, a template for yourself today. And if we look at the structure, we've got normally the preprocessor directives coming up first. We'll talk a bit about that. And also this one, we'll talk about it again. And then we have our main function, or the main function is called the driver function. I already have a recording for you, so I don't have to sit there. What that is basically when the processor starts executing, it wants to know which function that your main code is, or which function that it needs to start with, right? So we can have several functions in the same code, right? But it will just look for one specific function, which is the main function. Does it make sense so far? Yeah. So the driver function, pretty much, if you have other functions in the code, they need to be called by the driver function for it to be executed. At the moment, it's procedural, so it's just going to go in there and execute things line by line. So maybe from line 14, then go to the next one, all the way down. And something similar that I've done in the previous session, and I think is good. So I'm just going to do similar. We're just going to try to get rid of each line to see its impact on the code. Okay. At the moment, if I try to run this, it runs perfectly for me and it prints out hello world without an issue. So we all know comments are ignored. And as far as C++ is concerned, if we want single line comment, we can just go back. Make sure I resume the recording. You can just go back and add a single line comment here. I don't know, my first comment. Where does it keep moving? So I've got a single line comment. You notice that if I write anything or just say something else, it's not commented out because what I'm using single line comment in this particular case. If I want to get rid, add this as a comment to, I have this option, or I just use multi-line comment, which is the slash, a star, and again, a star and a slash to get rid of the whole file. Yeah. So if I run again, I'm safe, right? But let's just do something right now. I just want to add in my own header. You do the same for yourself as well. So I can just say, I don't know, give it a header. So description. And maybe you can put a date if you want. You can put the author, or you can just say by, and I can just go for myself. Just bear with me for a second, and I'll be with you. Actually. You choose your own date and then you can say hello world or something. Something meaningful, okay? Something meaningful. Question, answer.
Change it. Is it possible to change the points or the structure of the
Right. So at the moment, all we know is we've got our header. We know how to make use of a comment. We're going to start off by just getting rid of some parts of the code to see what its effect, whether it's going to run or not. So let's say if I don't include the content of the main function, so we know that if I comment out something, it gets rid of it. So I just get rid of the content of the main function. It runs without an issue, but the only problem is that it doesn't print out anything. You notice at the message at the bottom, it does say that the program finished with exit code 0. So the return 0 is, in this particular case, is somewhat implicit anyway. So it just sort of happens anyway. But as a good programming practice, we are still going to put return 0 for the remainder of the stuff that we write. So in case you export your code from one environment to the other, you don't want to have issues, okay? Yeah? So let's see. Go on.
I don't want to print the instead of I don't want to print the line and put this slash and stuff. That's very important. If
you don't want a line to be compiled, you've got two options. You can use, if it's a single line, you can use, let's do this. If you just want to get rid of a single line, you're just doing this. If it's multiple lines that you are getting rid of, you've got the option of repeating this on all the lines. Anything that follows it will not be printed out. So if I do this in the same line, this is just dealing with comments. This will be compiled, that won't be compiled, okay? So if I want it multiple times, I can repeat it, which is not really the most efficient way if I have a block of code that I want to get rid of, right? So I just use this option, which is the multi-line commenting. Yeah, so it's not that repeated. And remember, it is this instruction, the nature of the instruction is to print out to the console. That is why it's printing out. If it's not compiled, the instruction is not going to be executed. All right? Yeah? So I'll just get rid of this anyway, just because we have it there. Now we want to get rid of more things. So we notice we've got an open brace and a closing brace over there. What happens if I get rid of one of them? We expect to see an error because if you're opening something, we expect it to be closed at a certain point. Yeah, that simply shows that everything in here is a block. There is a block, there is a beginning, and there is an ending. If I get rid of the beginning without, and I provide an ending, the same way I get an error, right? This is the nature of a function. It's just how a function is defined. So we expect a return type. If the function returns nothing, if all the function does is to print to the screen, and there's no variable being returned, then we have a void. In this particular case, we know that the main function here returns an integer, right? The 0 in this case is an integer. That is why the return type is int in here, okay? So we have functions. Sometimes main can actually take parameters. That's why if you have a code that takes a file in place on other things. Currently, it takes no parameters, so it's void, so we're just leaving it as it is, right? So that's what we're expecting for this. So basically, we have the main function. We can get rid of other things to see its impact on the code. Let's get rid of this and see if the code runs successfully. It still runs without a problem. Let's get rid of the IO stream to see whether it runs successfully. It runs without a problem. But what if we have this? And then maybe that. Let's even make it more simple. And then we get rid of the main function, for example. Do we expect to see an error or not?
Yes, sir.
Why?
They're not all the same.
We expect to see an error because there is no driver function for the processor to run. You've written a code, but there's no driver function. You've got a bus which is set to move, but there's no bus driver sitting on there, right? Okay, so basically it does expect to see this main function. And normally any code that you write, you're going to have the input and output stream on there. What this says is that there is some standard code which has been written, most computers will come with it anyway, which has been written for you. And this standard code provide the inputs and output streams. It provide the ability to do things like printing to the console and other things. Yeah? Just give you the basic functions that you use. Good? I know you to be able to speak louder, so I can't hear you from where I'm sitting. So what we've established so far, we've got a preprocessor directives. We got rid of this earlier. Yep, go for it. No problem. We got rid of this earlier, and then we got rid of that also, okay? We know as long as we have the main function, it's going to run for us. I just want to try something else with this cout and print my hello world. So I try and I do get an error, and it's now telling me that it doesn't know what cout is. Basically telling me that cout on line 7, is line 7, line 14, column 7. So definitely quite specific. I like this, it's quite good. It wasn't declared in this scope, and so basically it doesn't know what it is, but it's giving me a suggestion to use the scope resolution operator, going into the standard library and using the scope resolution and then printing out cout. Now it understands, it's printed out my code to me, hello world to me, and I'm about to say, hello, Michael. Basically, how are you? You get it. So what this tells me is that this cout is sort of also defined somewhere else for me. Even though we've got an IO stream and everything, there's still something that's defined somewhere. It's just, and think of it as an alias, right? But it doesn't really know what it is. So how can it actually find this? It goes into this STD in here. And each time I want to use the cout again. So let's say I just want to do the same thing for this hello world, for example. I still have to put this before it. And I think it's quite tedious as well if you have a lot of CLs that you are going to use. So basically you use the namespace and it makes life easy for you to replace this. Okay. At the moment, it prints out without errors, but prints both of them on the same line. Any ideas if I just want to split this into two? Somewhere here, right? With the escape character and the new line over there. So that does the trick for me. Maybe I just want to separate what I've got on here so I can put this together, separate it from that. And I can split it, and we realize also it's the same thing. It has the same effect on the output. If maybe I just even want to be more cheeky, I can do something like this. Let's go for that. And realize it has the same output. So a bit more about the syntax, the scope. We notice that IOStream has no semicolon in terms of the preprocessor. We have this header, it has got semicolon at the end. For each statement, they end with a semicolon, but until we tell it to put a new line, it's not going to put it. So let's do this. Let's change this to, I'll be with you in a second, end line, And again, I'll put capital there and then run it. So at the moment, it's placed it for us. And we have end line being the same, if having the same effect as the \n. So I'll pause the recording here, give you the chance to write a bit of code now.
Yes.
So I'm not going back to my, just stay with me, okay? So first of all, we understand we are focusing on line 14 now, okay? This was pretty much similar to the code that we had before, right? Without the \n, it just basically, we have a literal, so everything that's in here is a string.
Yes.
It's going to take everything that's in there and print out to the screen, okay? So if I run it, we see line 14 being printed out, but right after what we have there, it goes on to print the next one for us because we've not told it what to do. We've not told it to split it, okay? And then we are just trying to think of a way that we can create the new line, and we have two options. One option is using the escape character and \n, and n, sorry. This one way of saying enforce a new line, but it needs to go into the brace as well, the string literal, but the escape character makes it a command. Yeah. An alternative of doing that is the same. This is sort of a concatenated way of writing a cout. Yeah.
Okay.
It's just, you know, cout begins with the two less thans, right? So this is also print out an end line, which is just print out new line. Make sense? So at the moment, I have two new lines together, so I'm expecting that there will be two spaces between the first one and the two that are printed. That's why you see the white gap over there. Does that make sense? Yeah? So there is, and we are saying that because this is the concatenated way, again, if we do this and we close this string on here, and we have another string on there, this comma is not a command, it's not a command, so I'll put that in a, let me do this anyway. I'll put that in this as a string as well, and the effect will be the same, just that I needed to put space here. Does that help to clarify things now?
Yes, sir.
Yeah? I'm going to leave my code here, and I'll zoom out a little bit. I don't see anything to close that thing on there, but oh, that's better. Okay, so at the moment, I'm printing hello, hello, Michael here and all that. Let's see whether we can get a bit of information from Michael or from the person after we said hello to him. So we have some things called containers. They are some things like containers. They're basically what? Variables. Okay. Container, think of it as container occupies space. So it's a specific space in memory. Yeah. So each variable will occupy some memory space. So before we use a variable, we need to tell the compiler how much space we need for that particular variable. Okay. The characters, which are the individual letters of the alphabet, plus the special characters and other things, they are what? Character variables. Obviously defined by the ASCII code, which is the specific ones and zeros that represent that. A small a, capital A, those kind of things. If you take ASCII code online, you find those definitions. We don't want to bother ourselves with that. So character variables occupy one of the smallest spaces. Usually I think they're about 8 bits. Yeah. is the same as the Boolean logic, which is 1 or 0, true or false. Okay? We have seen integer being used. Let's have integer variables. There are two ways that we can go about this, right? So we can have, let's say, integer x, meaning this particular memory space that we are giving the name x, it should occupy as much as an integer cannot occupy. Does that make sense?
Yes, no.
Yeah? What we are doing now, because int x is declared within the main function, we will say int x is what? Local to the main function. It's local to the main function. At the moment, we are all in this room. For someone to have access to us, they need to be in this room with us. Forget about mobile phones and Wi-Fi and other stuff. Right? Okay, but if you are standing outside the room, I can walk out of the door, I will see you. Another person can walk out of the door, they will see you. You get more access by being globally positioned to the other rooms. Currently, you are local. Once you are out of the room in the corridor, other people can access you. So you become what? Global. So if we want global variable definition, that is it. So at the moment, X is defined globally, and we will define Y locally to the main function. Does that make sense?
Yeah.
I'll add a bit of notes. Remember, if I do this, the semicolon comes before the comment, okay? Yeah, so those who were with me last week, probably this is the only thing I'm adding this right now. Can I continue? Yeah? I've only added two variables, X and Y.
What's the work of X and Y?
Sorry?
What's the duty of X and Y?
At the moment, it's just a variable. We just reserve the space in memory, and we told it it's going to contain what? An integer. So the variable declaration, at the moment, we have the name of the variable, and then we've got a type of the variable. So it's type and then name. Yeah? So there is, similar to cout, there is another one for taking input from the user. That's the cin. So think of it as cout is going out with 2 less than, the cin is coming in with 2 greater than, right? Know what I wrote. This greater than. So you're going to get cin maybe x from the user, which means we want the user to enter x. And maybe we just say, before that, can I change this to enter your age, right? So we're going to take the age and then maybe we print out your ages. Now, just think of it this way. At this point, please, you really want to pay attention when I'm giving it. So afterwards, you don't have to work backwards, yeah? Right, so at this point, we are taking a value and we are storing it into this particular memory location, yeah? So, which is called X, and we just print out X, we just simply taking the value of X and printing it back on the screen. Good? Yeah? So I can run through mine, hopefully without errors, and it's asking me for the age at the bottom. So enter your age, and then maybe I enter 4, and then it prints out your age is 4 at the bottom for me. So the code you have written, extend it so that it asks the user for an input.